We're about to take a trip, a pretty epic one. We're talking 4.6 billion years in the making. We're going to witness the birth, the life, and yeah, the absolutely catastrophic death of our home, the solar system.
You know, when you think about our sun, it just feels so constant, so reliable, right? It's just this gigantic nuclear fusion reactor hanging out in space. But it wasn't always this calm, stable star, not even close. Its story began in pure chaos 4.6 billion years ago.
So that's really the big question we're tackling here, isn't it? How in the world did we get from just a formless cloud of gas to the incredible planets and the star we see today? And maybe even more importantly, where is this whole show headed?
Okay, so here's our roadmap through cosmic time. We're going to start with that chaotic birth, check in on our stable present day, and then, well, we're going to have to brace ourselves for the catastrophic death that's waiting for us way, way down the line.
All right, let's hit rewind. All the way back to the very, very beginning, the birth of our solar system. It wasn't this gentle, beautiful thing. Nope, it was forged in pure violence, from dust and the absolutely relentless pull of gravity.
So, picture this, a huge, cold cloud of gas and dust just floating in space. And honestly, it might have stayed that way forever. But then, something gave it a shove. An external force. Could have been a shock wave from a nearby supernova. We don't know for sure. But whatever it was the cosmic starting pistol. It kicked everything off.
That little nudge triggered what we call gravitational collapse. And here's the cool part. It wasn't just happening in one spot. This collapse was going on in multiple places all over this giant cloud, creating all these little fragments, and each one of those was a potential star system just waiting to be born.
So as these clumps of gas and dust collapsed inward, they started to spin. See, even the tiniest bit of motion gets magnified thanks to something called conservation of angular momentum. It is exactly like watching an ice skater pull in their arms to spin crazy fast. The cloud did the same thing. It spun faster and faster, flattening out into this spinning platter we call an accretion disk. Now, right at the dead center of this spinning disk, the pressure just became immense. All that gas and dust getting squeezed together so unbelievably tight, the temperature just skyrocketed. We're talking 15 million degrees Celsius. It's almost impossible to even wrap your head around that kind of heat.
And this is the moment it all happens. At that insane temperature, the natural force that pushes positively charged hydrogen atoms apart, it just gets completely overwhelmed. They can't resist anymore. They slam together, they fuse, and boom! In a flash of energy that is truly unimaginable, our sun ignites. A star is born.
Okay, so the sun is officially switched on, but the story is far, far from over. Now we've got to look at the rest of that spinning disk, because that's where the planets were being built from all the leftover chaos. Look, making planets is a seriously messy and violent business. It starts tiny, with little dust particles just clumping together. But these clumps grow, first to tens of kilometers wide, then hundreds. And at that point, they become the bullies of the neighborhood. They're gravitationally dominant. They basically turn into cosmic vacuum cleaners, just sweeping up all the gas and dust in their way until, eventually, you've got a full-on planet. Sometimes they'd even snag some other material into their orbit, and that's how you get moons. And let me be clear about this. The early solar system was a cosmic shooting gallery, an absolute war zone. We're talking about just massive, world-shattering destruction from giant impacts between bodies the size of planets. This was not a peaceful construction project, it was a demolition derby on a cosmic scale. So you might be wondering, what about all the stuff that didn't get pulled into a planet? Well, that's where our comets and asteroids come from. They're the cosmic leftovers, the debris that couldn't get an invitation to the planetary party. They just got kicked out into these weird, eccentric orbits. All right, let's hit the fast forward button. A few billion years later, 4.6 to be exact, the chaos has finally settled down, and we arrive at the solar system we all know and love today. Our stable, mature, cosmic home address. Today, our sun has a fancy title. It's a G-type main sequence star. That's really just a technical way of saying it's in the prime of its life. It's in this super stable, long-lasting phase, just steadily turning hydrogen into helium in its core. Its energy output is nice and reliable. For now. And of course, circling around it, we've got the whole gang, our familiar lineup of planets. Each one has carved out its own lane, gravitationally speaking, from our neighbors Venus and Earth, all the way out to the huge gas giants like Jupiter and Saturn. Yep,
This is the family photo.
But wait a second. If you think Neptune is the edge of town, you've got to think way, way bigger. The real boundary of our solar system is this unfathomably gigantic sphere of icy comets called the Oort cloud. I mean, this thing is enormous. It completely surrounds our entire system. It's kind of like the second line of our cosmic address. And now we have to turn to the future. And I'm sorry to say, it's not pleasant. This stable home that we know and love, it's temporary. The sun's final act is going to be nothing short of catastrophic.
The thing is, the end isn't like flipping a switch. It's a really slow burn. As the sun keeps fusing hydrogen, its core actually compresses and gets hotter just to keep everything in balance. And a hotter core burns fuel faster. What that means for us is that the sun gets brighter, about 1% brighter every 100 million years. Now that might not sound like a lot, but believe me, over cosmic timescales, the consequences are enormous.
And then, about 5 billion years from now, the inevitable finally happens. The tank runs empty. The hydrogen fuel in the sun's core is gone. That outward push from fusion, the thing that's held the sun up for billions of years, it just stops. And without it, gravity is the only king in town, and it will start to crush the core, completely unopposed. This is the big turning point. That crushing gravity makes the now dormant helium core heat up like crazy. This in turn superheats the layers of hydrogen still sitting around the core, causing them to start fusing in a shell. All of this new intense energy has to go somewhere, and it pushes the sun's outer layers outward, expanding dramatically. A red giant star is born. So as the sun swells up to this monstrous size, its own gravity on its surface gets weaker, and an extreme solar wind just starts blasting its outer layers off into space. This whole expansion, it's absolutely catastrophic for the inner planets. Mercury and Venus, gone, completely engulfed. Earth's fate, well, we're right on the edge, but it's very possible we'll be swallowed up too.
But honestly, whether our planet is physically eaten or not, it almost doesn't matter. Long before that could happen, the intense heat from the expanding sun will have boiled our oceans dry and completely stripped away our atmosphere. Let's just be crystal clear about this. All life on Earth is 100% guaranteed to die. But believe it or not, the sun is still not done. Its time as a red giant is just one phase of its death throes, and it's going to keep getting bigger and brighter, pumping out so much energy. So what happens next? Well, for that, you'll have to stick around. Go ahead and click one of the videos on your screen right now. We've got more content that will completely blow your mind.